guys, hope you're doing great. Our today's question is burst balloons. So given n balloons indexed from 0 to n minus 1, each balloon is painted with a number on it represented by array nums. You are asked to burst all the balloons. If you burst balloon I, you will get nums left into nums I into nums right. So both the adjacent values to I, that many coins. Okay. Here left and right are adjacent indices of I. After the burst, the left and right then become adjacent. Okay. Find the maximum points you can collect by bursting the balloons wisely. Okay. So you may imagine nums of -1 equals to nums of n equals to 1. Okay. They are not real, therefore you cannot burst them. So this is just telling that, for example, in this given input, if we burst the balloon 3, so since there's nothing to the left of it, so we can assume that that's 1. So we take the value 1 into 3 into 1, right? And similarly for 8, it will be 5 into 8 into 1. So this is the answer, right? So the balloon 1 with 1 coin was bursted first, and then the one with 5, and then the one with 3, and then finally the 8. So that is how it is represented: 3 into 1 into 5, right? 3 into 5 into 8, and 1 into 3 into 8, and then 1 into 8 into 1, which gives us 167. Okay, so this is an unsorted array, and there are a bunch of techniques that we can use to solve questions on that. So let's have a look. So please pause the video, think for a moment, and come back. So this one is like really a tricky one and clearly does not fit in any of the given approaches here on the slide, and that's why it's dynamic programming that we need to use to solve this question. So let's get started with the solution. So it's really important to understand what we are doing here, and hence I have like written this really small explanation or pseudocode. So we clearly know that if, for example, if I'm bursting the balloon 5, right, the number of coins I can collect by bursting 5 is 1 into 5 into 8. Right? So this is the very, very basic thing that we need to be very clear about before diving into this. Okay, so now what we do is, now let's have a look at this. Right. So let's assume that there's a function that we are writing, okay? And if I'm saying that this is my number and these are the indexes of these numbers. So if I'm saying that for 0 to 3, right, the 0 index to 3 index, I apply this function and I want to find the maximum number of coins that I can get, the order in which I should do it. So I basically need to first of all find which is the first balloon that I should be bursting, correct? Okay, so what we'll do is that we'll assume that 3 is the last balloon that will be bursted. Okay, so if 3 will be the last balloon to be bursted, then obviously there will be no other balloons left in this array, right? So there'll be like just 3, and hence the left to it would be 1, and to right of it would be 1. So 1 into 3 into 1, and then we recursively apply this to 1, 3, that is this sub-array. Okay, so this indicates that if I burst 3 the last, then what will be the answer? Similarly, if I burst 1 the last, then I need to combine the result for 3, right, plus the one for 2, 3, that is this, because 1 is in the middle. If I burst 5 in the last, then it means I've already bursted 3, 1 and 8, right? So we can have a recursive call to 0, 1, right? 0 to 1 and 3, 3, that is 8. Okay. And if I burst 8 the last, then it's basically these three have been bursted and you want to get the max out of those. Correct? Okay. So I hope this much is clear. Now with this, we'll just think about what will happen inside this. Okay. So let's say if we're talking about 1, 2, 3, that is 1, 5, and 8. Okay. That is the sub array that we are working on right now. So here again, it's pretty similar, but now here since we have a number to the left of 1, right, because we are working on a subarray, so what will happen is that we'll be if we assume that 1 is the last balloon to be bursted, it means 5 and 8 have been bursted, right? So if 1 is the last one to be bursted, 5 and 8 are not there, so to the left of it we have 3, and to the right of it would be 1 because 5 and 8 are already bursted. So we'll take 3 into 1 into 1 plus the function of 2, 3, which is 5 and 8. If we say that 5 is the last one to be bursted, then we'll still have 3 to the left, nothing to the right. So 3 into 5 into 1 plus the function of 1, 1, and 3, 3. And similarly for 8, right? So that is how we calculate the same thing for a subset, right? So as is clearly indicative here that we can use recursion to solve sub-problems and then use those to, so for example, we needed function 1, 3 here to derive 0, 3, right? So if we have these pre-calculated, we can calculate this, and this is a classic example of dynamic programming, right? That when you have sub-problems which can be reused, the results of those sub-problems can be reused to build up a better or a bigger solution. That is when we need to use dynamic programming, right? So with this, a very simple formula can be used that if I and j are my left and the right extremes, or basically the left and the right boundary of the subarray that I am currently working on, right? It could be just 1, 3, 0, 0, anything. So that's my I and j, left and right boundaries. And for each k in this, okay, I just have to get the maximum of, right? So for k, basically nums of I minus 1 into nums of k, right? And nums of j plus 1. So before the boundary starts, the left boundary starts is I minus 1. After the boundary ends for this subarray is j plus 1, because I and j are the left and the right extreme boundary points for this, into the nums of k, just like here. So 3 into 1. So 3 is the left, that is nums of I minus 1. 1 is the nums of k itself. And then j plus 1 is basically because j is equal to the length of the array. So j plus 1 is 1, right? And then to that, we have to add these depending on where is k between I and j, right? So if it is in the middle, for example, in this case where 5 was in the middle, so we had elements to its left and we had elements to its right. So we just want to use this pre-calculated result, the DP result, for I k minus 1, right? So k minus 1, and then we skip k and k plus 1 to j. Okay, so this is the formula that we'll be using to get our final answer. Okay, so let's get started with the implementation. So base conditions first, nums dot, let's calculate the length first actually. So length is nums dot length, right? If length equal to 0, return 0. There are no points. so we cannot make any money. Okay. Also now we'll need a two-dimensional array. Let's call it dp, and it will be length by length. Okay, fine. So now what we'll be doing is that, as you can see, we need a lot of sub arrays to be solved, right? So the length of the arrays that we need to solve is starting from 1 to 2 to 3 and then finally our answer. So that's why we need to basically compute the same for smaller arrays with 1 element, then 2 elements, then 3 elements, right? So what we'll do is a very simple thing. We'll just start n, right, from 0. Okay, n is less than, okay, what is the name of our array? Yeah, nums. Okay, nums dot length. Okay, oh yeah, we have calculated len, and I, oh sorry, I and not n plus plus. Okay, fine. Now with this value, we'll create the left boundary and the right boundary. Okay, so for int I equals to 0, I less than, sorry, I plus n less than the length. Why? Because we want to ensure that there are n elements after the last thing that we choose. So there are n elements between the end of the array and where our I is. So that's why we ensure that I plus n is less than n, and we go only till we have that many number of elements ahead of us, right? And then we do an I plus plus. Cool. And then we have our j, that is the right boundary, equals to I plus n. That's really simple. Okay, so now comes into place our k, which will be equal to 0 first, and then k will always be less than equal to j. So we are traversing the sub array now, which starts from I and ends at j, right? And k plus plus. Cool. Okay, so now I'm just thinking if we need this n to be 1, because we at least need the length to be okay, fine, let's see. Yeah, so we are traversing from 0 to I. No, actually we're traversing from I to j. Yeah, sorry about that. Okay. Right, so let's calculate these components now, all these components, right? So we'll just call them left, for example, left number. So if my I, right, that is the start boundary or the left boundary of this subarray. So if I is 0, then there can be nothing on the left of it, right? So then it's 1, because the question states so. -1 is 1. Otherwise, it is nums of I minus 1. Cool. Similarly, right num equals to, if j equals to length minus 1, that is, it's basically 8, right? So then it is going to be again 1. Otherwise, nums of j plus 1, the next one. Okay. So this is the calculation of the nums of I minus 1 and nums of j plus 1. Now let's find out these. So we'll call them left and right. So that depends on k's position, right? So if k is equal to y, that is, it's the first element of the subarray, then, right, then we'll have nothing to the left of it, so just 0. Otherwise, we'll have dp of I and k minus 1. And similarly, right equals to k equal to j, then 0, because then it's at the right end of the subarray, so nothing. And then dp of k plus 1 of j. Okay, and since we have these, let's just do the last bit. So we want to maximize it, so math.max of whatever dp of I j has already. If that's more, then fine, we don't want to update it. Otherwise, let's put them all together. So left num into nums of k into right num plus left plus right. Yeah. Okay, that looks decent. Once this is done, since we have been using all of this to basically build up what we wanted to like do, which is 0, 3, so what we have to return is dp of 0 and length minus 1. Okay. Okay, that looks decent. Let's see if that works. Oops. Oh, that's too bad. Yeah. Oh my god, okay. Sorry guys. Typos. Okay, that works. Fine. So the time complexity of this is O of n cube, because we are using these 3 loops, which is like really clearly visible. And the space complexity is O of n square, because given the length n of nums, we are creating a dp which is n square of that. So I hope this question and the solution helps, and you completely understand the solution. If you do, please like, share and subscribe. Keep coding and take care, guys.